Welcome back. Let's discuss on Spring Boot 3.0 with microservices communication, how the microservices are communicating. In the previous section, we have developed all the required services for our project. We have developed the flight service, flight search service, and the booking service. However, what is still missing is the communication between the services in our project. In a microservices architecture, services usually communicate with each other. There are two types of communication between services, synchronous and asynchronous communication. Now let's learn something more about the synchronous communication. As we have told, in synchronous communication, service A sends a request to the service B and it waits for the response before continuing its execution. It's like making a phone call where the caller waits for the receiver to answer the call and have a conversation before hanging up. The key characteristics of synchronous communication are blocking. When service A sends a request to service B, service A blocks its execution until it receives a response. This means service A is idle and cannot do anything until the response arrives. Request response model. The interaction follow a request response pattern. Service A sends a request, service B sends back a response containing the requested data or the result of the operation. Simplicity. Synchronous communication is relatively easy to understand and implement because it naturally fits into the traditional request response paradigm. Asynchronous communication refers to a mode of data exchange or interaction where the participants do not need to operate in real time or simultaneously available for the exchange of information. In asynchronous communication, the sender and receiver are not required to be actively engaged at the same time, and there is often a delay between when a message is sent and when it received or be processed. Let's learn some of the asynchronous communication characteristics. The first one is non-real time. Asynchronous communication allows for delays between messages, transmission and reception. So participant can communicate on their convenience until the messages are stored and they are received. The next one is convenience. Asynchronous communication offers flexibility, allowing individuals to communicate when it's most convenient for them. This is particularly useful when dealing with participants in different time zones or busy schedules. Then, message persistent. Messages are often stored for future reference. For example, email messages remain in your inbox until you choose to read or delete them. This feature is valuable for archiving and record keeping. The next one is reduced pressure. Asynchronous communication can reduce the pressure to respond immediately. Participants have the opportunity to think, research, or gather information before composing the response. Threaded conversation. Many asynchronous communication tools support threaded conversation, making it easier to follow and respond to specific messages with a larger discussion. The next one is collaboration. Asynchronous communication is valuable for collaboration on documents and projects, as participants can make contributions at different times without needing to coordinate their efforts in real time. The next one is notifications. Many asynchronous communication tools provide notification to alerts user when they have new messages or update. This will help user to stay informed without constantly checking for the updates. Then we have information distributions. Asynchronous communication is often used for sharing the information such as newsletters, reports and announcements to a wide audience. And the final one is message queues. In software development and distributed systems, asynchronous communication is essential as it involves the use of message queues to pass messages between different components or services, which will help them to work independently at their own pace. So when to use synchronous and when we should use the asynchronous communication. Unlike synchronous communication where participant interacts in the real time, means simultaneously, asynchronous communication allows for delays between the message transmission and reception. Participants can communicate at their convenience and messages are stored until they are retrieved. Email, voicemail, text messaging, discussion forums, and asynchronous collaboration tools like shared document editing platforms, for example Google Documents, are some of the common examples of asynchronous communication. So in short, synchronous communication is typically used when the client requires an immediate response and cannot proceed without it. For example, when retrieving data for a web page or performing a critical operation that requires the confirmation. While asynchronous communication is useful when the client can proceed without immediate response, or when the response time might vary or unpredictable, or when there are the time differences, the need for careful consideration is required in the response, or when individuals are managing multiple tasks and can't engage in the real time conversation. It can help to decouple the services and provide better scalability and fault tolerance. It's a fundamental concept used in various fields including technologies, business, and interpersonal communications. In microservice architecture, both synchronous and asynchronous communication patterns are commonly used based on the specific use case and requirement of the services involved. The choice of communication method depends on the factors such as performance, scalability, and the nature of interaction between these services. Now let's see some of the flight booking use cases for synchronous communication. Flight availability check. When a user searches for available flights on a particular date, the system performs a synchronous query to the airline database. The user receives the immediate response, such as list of available flights and their prices. After a user selects a flight and proceeds to book it, the system performs synchronous communication with the payment gateway. The user waits for real-time confirmation of their booking and payment. The next use case will be seat selection. If a user wants to select a specific seat on the plane, the system communicates synchronously with the airline reservation system to check seat availability and assign the chosen seat to the user. Another use case will be real-time price updates. In some cases, airline may offer real-time price update for a specific flight. The user can see the price change in real time as more seats are booked or the departure date is coming soon. We can see now flight booking use cases for asynchronous communication. Flight delay notifications. Airline can send asynchronous notification to passengers about flight delays or cancellations via email, SMS, or push notifications. Passengers are not actively requesting this information but receive it when they are needed. The next use case is waitlist notification. If a flight is fully booked, passengers can opt to be in waitlist. When a seat becomes available, the system sends an asynchronous notification to passenger on the waitlist. Another use case will be baggage tracking. Passengers often want to track their checked baggage. The system can provide asynchronous update on the baggage location and status throughout the journey. Feedback and surveys. Airline can send asynchronous email to the passengers, offer their flights, requesting feedback or providing post-travel service. Passengers respond at their convenience and the feedback is collected over the time. Flight status updates. Airline can offer passengers the option to subscribe to the flight status updates. These updates can be sent asynchronously, providing information about the flight's departure, arrival, and the gate changes. Ticket refunding processing. When a passenger requests a ticket refund, the refund process often involves asynchronous communication. The passenger submits a request and the airline processes it with the notification sent when the refund is approved and processed. I hope now we have understood very clearly what is the synchronous communication and what is asynchronous communication. Now moving further, we will see how we can use the synchronous communication and asynchronous communication using microservices. For synchronous communication between microservices, we can implement it using various approaches such as RestTemplate, Webclient, FeignCLient, and HttpExchange. RestTemplate is a part of Spring Framework and used for making HTTP requests to interact with RESTful web services or APIs. It simplifies the process of sending HTTP requests and handles response in Java application, particularly in Spring-based projects. This is one of the older way to interact with other microservices. If we follow the Spring documentation website, we can see the definition of REST template. It is using for synchronous communication, and if you see the note here, as of 5.0, this class is in maintenance mode with only minor requests for changes and bug to accept going forward. So it is recommending for the web client. Web client. Now web client is a non-blocking reactive client for making HTTP requests in Spring Boot applications. It's a part of Spring Webflux project and is suitable for building asynchronous as well as synchronous reactive microservices. And we can see its uses in various HTTP operations for making the request using get, post, put, and delete. In the Spring Framework document site, if you go, you can see for the web client. It is a non-blocking reactive client to perform HTTP requests as we have discussed. And this also supports the reactive way to handle this client. So we can see the information related to Mono and Flux. Also you can go through it and you can see how we are using this application. So in the Spring Initializer website, if you try to add the dependency for Webflux, you can see the Spring Reactive. So this Spring Reactive Web will help you to develop the Spring Webflux and native web applications. FeignCLient. So FeignCLient is a declarative web service client in Spring Boot that simplifies the process of making HTTP requests to other services. It is designed to reduce the boilerplate code and it allows you to define the HTTP client using interfaces and annotations. You can see more information in Spring Cloud OpenFan website. So here if you can see, it has dependency on Spring Cloud OpenFan and it will provide the detailed information about the declarative approach and how we can use it. We need to do some configuration enable for this thing. All this thing we will cover in my next video. In the Spring Initializer, you can search for a dependency called as OpenFan. So here you can see this is a declarative REST client. OpenFan creates a dynamic implementation of an interface with JAX RS or Spring MVC annotations. From Spring Boot 3.0 onward, HttpExchange is widely used. In this approach, microservices communicate with each other over HTTP using RESTful APIs. One microservice acts as a client and sends HTTP requests to another microservice, which acts as a server and responds with the data. So you can use the HttpExchange to make get, post, put, and delete requests to other microservices to retrieve data, create records, update resources, or delete the data. In the Spring documentation website, you can find the information related to HttpExchange interface. It also needs some declarative approach and we can see in detail about all this thing how we can use the different exchange mechanism for our application. There are several ways to communicate using asynchronous communication in Spring Boot and microservices. We have messaging services and so on. For our example, we will be using the Kafka implementation. If we can go to the Apache Kafka website, we can see the definition here. Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming analytics, data integration, and mission critical applications. Kafka has several key features like publish subscribing messaging system, stream processing, high throughput and low latency, persistence, fault tolerance and replication, and distributed and scalable. You can see more detail for Apache Kafka in the Spring website, and here you can see the different information related to what's new in each of this version, along with the different ways how we can implement this thing. All this link information you can find in my description. In my channel you can find one more video, building scalable microservices with event-driven architecture using Apache Kafka and Spring Boot 3.0. Here I have provided in detail what is Apache Kafka and what is event-driven architecture and how we can use this in Spring Boot 3.0 application. In my next video, we will cover both the synchronous and asynchronous communication in Spring Boot microservices using Java. There we will cover the communication of booking services with flight service and payment service as a synchronous communication, and for notification service we will see using Apache Kafka asynchronous communication.